Hi everyone, this is the Virtual Physicist. Did you know that sounds can produce silence? But how can it be? And first of all, what is sound? Sounds are just pressure waves that propagate in the air, water or other materials. Somewhere there is an impulse. The first molecules in contact with it push the others next to them, and the one pushed push the one next to them, and so on. After pushing, molecules tend to expand because they have been compressed, and doing so they compress the molecules nearby. The sound, therefore, is an oscillation of molecules that gradually goes down. This phenomena makes oscillates our eardrum that gives us it, the sound. Now, given what we said, there exists a phenomena called interference. Interference happens when different pressure waves meet each other. Their behavior is that they simply merge. And here's the point. If one wave would have compressed the air and the other would have expanded the air, we have what is called destructive interference. They cancel their behavior, producing therefore silence in that point where these things happens. All this is very nice, but it's a bit theoretical, so let's look for some cool use of this. Did you know it's possible to tune your guitar even without the perfect pitch if you have just one string tuned? Actually, it's pretty easy thanks to beats. We'll see in a moment what beats are. If you have two sound sources of similar amplitude, where by amplitude we mean the intensity of the sound, and almost equal frequency, this happens. Waves can be described by this formula. The amplitude times the cosine of the frequency times the time. Since we have interference, what we do is just adding them, and by the prostaphäresis formulas we get this. That the sum is just 2a times the cosine of half sum times t times the cosine of the half difference of the frequencies times t. Now, this is a bit weird maybe at a first glance, so let's look at it piece for piece. We can break up the formulas in two terms, the first cosine and the second one. The first has a really high frequency that is given by the sum of the two. The other term instead is pretty low, remembering that by assumption the frequencies were almost the same. We have therefore a slow sinusoidal that oscillates rapidly. We can now write a simple program that plots this for us. The program is written in Python. You can find the code in the description of the video. Basically, every frame the program just plots the wave, and over time the wave moves. We can clearly see that the wave is just a fast sinusoidal whose amplitude varies in a sinusoidal fashion. It's now evident that when the slow cosine approaches zero, we have a time where the amplitude is very low, and the wave continuously changes between loud and silent. We call this beats. Now, coming back to the guitar question. The tuning goes like this. Suppose our 6th string is tuned. If you press the 5th fret of the 6th string, it makes the same note of playing the 5th string. Now we just have to play the 5th fret of the 6th string and the 5th string at the same time. And changing the tune of the 5th string, we look for when the beats are more farther apart as possible. This is because the slow term has a frequency given by the difference of the frequencies of the two notes. If they get closer, the difference tends to zero, and therefore the beats are slower. So this is what beats are and how you can make silence out of sound. See you in the next video.